Hey guys, welcome back everybody. So if you guys remember that we have discussed like a static route. We have configured the static route in the three ways, right? So first we have discussed like how to configure the static route with the next stop concept. Then we have seen that how to configure the static route with the exit interface, and then also we have seen that with the combination of the exit plus next stop, right? So today in this lecture, right, we are going to discuss about what is the major difference between the next stop and exit interface, and why we are going why we are going to use the combination of this static dot exit interface plus next stop, right? So if you see my topology, this is my router number, that's the customer router, and we have this is the ISP router we have, and behind the ISP we have a few loopbacks. We can consider as a 1.0, 2.0, 3.0, 4.0, and 5.0. All are the class A IP address. Same thing, we have 6, 7, 8, 9, 10. These are also class A IP address. So what I'm gonna do right now, I'm gonna give the 5 static route on the router number 1 towards the next hop. And for this guy, I'm gonna use the exit interface. What I'm saying that, so on the router number 1, on router 1, I'll give the static route IP route, because if you check my routing table right now on the router number 1, I don't have any route. Show IP route, I just have a single route. And if you check my interface configuration, show IP interface brief, I just have a 12.1 on this particular interface. If you have a look at the MAC address, show interface 0/0 include BIA. You can see that this is the MAC address of this particular interface right now. Same thing on the router number 2. If you have a look, show IP interface brief, I have a 12.2 and 10 loopbacks. Right? Same thing if you have a look at the show IP route right now connected. I have a multiple route in my routing table. So from the customer side, right, what happened? Whatever the user are sitting behind the router number 1, they wants to send the traffic to the all this particular network, right? So we need to give the static route on the router number 1. So we have a two ways to give the static route, and then we'll understand the difference between these two command line. So the first 5, I'm going to use the next hop. I see the IP route 1.0.0.0 and submit mask, and the next hop will be 2.2, right? On router number 1. Same thing, I'm going to use the IP route 2.0.0.0 submit mask, and the 2.2 IP route 3.0.0.0 submit mask, and then we have a 2.2 IP route 4.0.0.0. Come on, and submit mask and 2.2. Same thing, we have a IP route 5.0.0.0.0 and 2.2. And then the remaining 5 the 6, 7, 8, 9, 10, I will give the exit interface 6.0.0.0.0, and also use the 0/0. That's my router 1 interface. Same thing, IP route 7.0.0.0. I have a 0/0. So sorry, 8.0.0.0.0. Then we have a 9. And sorry guys, 10.0.0.0, and then we have a 0/0. All good, right? So we just define all this route, and let me copy and paste this configuration router number 1. So let's go config terminal and let's define the route. So first you have to understand the major difference is what. So if I'm going to use the next hop configuration, so in the next hop configuration, what happened? A router, of course, you need to have a MAC information, right? Because before gonna send the layer 3 packet, you need to have a complete layer 2 information, because if you don't have a source and destination MAC, you cannot complete the packet, right? Otherwise, if you don't have a destination MAC information, then what happen? Encapsulation field and the packet will be dropped. So normally in that case, what happened whenever you don't have a MAC, normally you need to use the ARP protocol, right? To get the MAC address of the destination PC or destination host, right? So what happened in that case, when you're going to use the next hop interface, then router 1 will generate the ARP request, right, for next hop IP. Understand the concept. Router 1 will generate the ARP request for the next hop IP. It means that, understand the concept, whenever the I'm going to send the traffic, right, when I say the ping, hey, ping 2.1.1.1.1, if you see all this 1.0, 2.0, 3.0, 4.0, and 5.0, I give the next hop, right? So when I say the ping 1.1.1, in that case, what happened? Router will generate the ARP request for the next hop IP 12.2, and router 2 will give the reply. So in this case, normal ARP comes in the picture. Normal ARP, right? So I'm gonna send the request to the 2LR2. Hey, I need a MAC address of the 2LR2, and R2 will give the reply. That's a normal ARP. But when I'm gonna use the IP route destination network subnet mask and exit interface, in that case, what happened? Router 1 will generate ARP request for each IP address, destination IP address. And it means that if now I'm going to send the traffic, I say the ping, let's ping the 6.6.6.6.6. If you see, this is the 0/0 exit interface we have, right? In that case, what happened? Now the router 1 will generate the ARP request for whom? Router 1 will generate the ARP request for the destination person. So understand the concept. In the first one, what happened? Let me use a different color. In the first case, what happened? When the router 1 is going to send the traffic to the 1.1.1, it will generate the ARP request for the next stop only. In that case, my ARP header something like this way. We have a source MAC will be, of course, A, destination MAC will be, I'm just considering it A and B, of course, like you, let me put the complete one. I'll say the C201, right? And the destination will be what? The destination will be, of course, the Ethernet header will be FFF, right? And then we have a C21, C201, destination will be 0000, source IP will be, of course, 2.1, and destination IP will be what? The destination IP will be 2.2 in this case, next stop one. But when I'm going to ping, as the ping 6.6.6.6.6, right? In that case, what happened? The router 1 is going to generate the ARP request, right? C201, that's of course source MAC will be there, and destination MAC will be FFF. Now the C201, right? And destination will be 000. That's a MAC address, and source IP will be what? That's a 12.1. And destination IP will be what now? What? Destination IP will be 6.6.6.6. Can you see the difference over there? This is the 12.1. That's I'm going to generate the ARP request for the next hop IP. But now we have a 6.6.6.6. That's our destination one. So in that case, what happened? Try to understand when I'm going to make a request. Hey, I need a MAC address of the 6.6.6.6. R2 will say that, hey, I don't have a 6.6 in my local routing table. Because understand this concept, this is the different broadcast domain, right? And this is a different broadcast domain. Each loop back treats like a different broadcast domain. And ARP is your layer 2 packet. It cannot cross. It cannot cross from this interface to the another interface, right? This interface is the border of the broadcast domain, right? So when the ARP request comes over there, what R2 will say that, hey, you cannot cross it. So in that case, what happened? By default, on your router interface, proxy ARP is enabled. By default on your router interface, proxy ARP is enabled. So here will be guy over there, and this is the guy name is a proxy. What proxy is going to do that? It seems like your classroom, right? So whenever you are absent in the class, normally what happened? There is some friend, right? So there's some guy who will do the proxy for you. Same thing is going to do that over there. So R2 is saying, hey, 6.6.6 is not part of this broadcast domain. So on this particular interface, the proxy is present on the behalf of 6.6.6.6, right? On the behalf of 6.6.6.6, R2 will give the reply. On the behalf of 6.6.6, R2 will give the reply because of the proxy ARP. So if you're going to use the exit interface for this one, your proxy ARP must be enabled. Now understand the things in the debug label. So what I can do that, I'll just gonna send the packet from the router 1, and I'm gonna enable the debug ARP. And if I'm gonna say the ping 1.1.1.1, try to understand. If I'm gonna say the ping 1.1.1, in that case, what happened? I'm gonna generate the ARP request for the next hop. Can you see that? So I'm generating the ARP request for the 2.1. That's my source IP address of this guy. Of course, C201, that's a MAC address. And the destination will be 2.2. Right? Let me copy and paste this thing in the man. Oh, 1 minute. Let me copy and paste in my paint, then you will understand more clearly. So this is for, okay, let me decrease the size. Come on. So that's for the next hop, right? If you're gonna use this configuration. I don't have a space, so I'll make it small a little bit. Right, here we go. And that's this one will be in different color. Right, so you can see that I'm generating the ARP request for the destination person. It's 12 or 2, right? Next hop guy, not this. If I'm going to use this command line, in that case, there is no need of proxy ARP. In that case, there is no need of proxy ARP. Now understand, if I'm going to ping, what happened? If I'm going to ping the 2.2.2, do I need to generate the ARP request? Of course not. The reason is that because for this guy, already I have a 2.2, right? So in this case, what happened? If I already have a ARP entry for the 12.2. If I already have a ARP entry for the 12.2, my next stop, I no need to generate the ARP request. If I'm going to ping the 3.3.3, no need to generate the ARP request. If I'm going to ping the 4.4.4, I already have a ARP entry for the next stop. No need to generate it. If I'm going to ping the 5.5.5, I already have a ARP entry for the 12.2 because all this 5 network 1, 2, 3, 4, 5 has a next hop configuration. And for the next hop configuration, what happened? I just need to generate the ARP request for the next hop IP, and I already have an ARP request for the next hop. So no need to generate the ARP request. And there is no need of proxy ARP. But if I'm going to ping 6.6.6.6.6, that's for the exit interface. For each and every destination IP, you need to generate the ARP request. Have a look. So now let me copy and paste it. And now if you see, let me go in the different color. All right, and let me little bit. It's 14 is fine. And I'll put this guy over here as well. For this case, your proxy ARP must be enabled. Okay, this one, go with the different color. And now you can see that. Okay, and now I'm setting the destination. You can see the 6.6.6.6.6. That's a major difference is that. Right, so you may have a question, hey, law, still I'm able to send the traffic. That's not a big deal. Okay, I'm not denying it. If I'm going to ping the 7.7.7, what happened? Do I have a ARP entry for the 7.777? No, I don't have. If you check my ARP entry right now, so ARP, I don't have a ARP entry for the 777. I have to generate that request because 777 is still using the exit interface. So take example, if you have a 10,000, right? Understand this concept. If you have a 10,000 route with the next hop, how many ARP entry you will have? You just have a single ARP entry, one ARP entry. If you have a 10,000 prefix, I'm talking what? Prefix a route, we can say that. For all the routes, you just have a one ARP entry, right? But if you just have a, right, I'm not talking about the routes. I'm just talking about if you have a 10,000 IP addresses even, only IP addresses, right? You can have a all this 10,000 IP address in the single class A IP address as well, right? For all this IP address, you will have a 10,000 ARP entry. So if I talk about the memory perspective and CPU perspective, it's totally vistas of the router resources. If you're going to use the interface. So now if you see over there, if you see right now, I just generated the ARP request for the 7.7.7. If I'm going to ping the 8.8.8, I have to. See, if I'm not picking the 9.9.9.9, I have to. So if you see the so ARP, what you can see that our multiple ARP entries for the 6, 7, 8, 9. But just I have a single ARP entry for this guy because this is the person for the all the next hop configuration. This is for the all the exit interface we have. And can you see one thing? What I told you that on the proxy app concept. So he will make a request. I need an ARP entry for the 6.6.6. 6.6.6 is the part of the different broadcast domain. R2 will give the reply on the behalf of 6.6.6.6. So if you see what happened, you have a same MAC. Can you see that? R2 MAC address C202, 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 C202. All they have same MAC address because R2 is giving the reply. Because Proxy ARP is present on the router number 2 interface. If you have a look on the router number 2, so interface 0/0 include proxy, right? Wow. So IP interface 0, sorry. Proxy P should be capital. And you can see that my proxy ARP is enabled. If I'm going to disable it right now, I have a look over there. So the interface 0/0, no IP proxy ARP. What happened in that case? Now the proxy is gone. Now the proxy is gone. Proxy is not present in your classroom right now. It's not present in your broadcast domain. So now if I'm going to send the traffic with a 10.10.10, have a look. I still have a 10.10 in my routing table, right? If you see that routing table, so IP route, I have a 10. Can I send the traffic to this guy? No, I can't. Because proxy ARP is mandatory for the exit interface static route. He's trying to send it, right? He's trying to send the packet for the distance 10.10. Hey, I'm looking for the MAC address for this guy, but nobody is responding it. The reason is that R2 doesn't have a proxy ARP is enabled. So can I send the traffic with the 6.6 right now? Yes, I can, but I cannot send the traffic with the 10.10. I can send the traffic with the 6.6.6 because the reason is that I already have a ARP entry for the 6.6.6. So I'm using my this database to send the traffic. Of course, after the 4 hours, if you just remove this entry, then you cannot send the traffic. By default, ARP timeout is a 4 hours, right? On the router interface, Cisco router interface. If you see, so interface 0/0, the default ARP timeout is 4 hours. What is that? So if I'm going to remove this ARP table, take example, I say the interface 0/0, shutdown and no shutdown, right? So all my ARP will be flushed. So ARP, I don't have any entry. So let's ping the, so now the proxy ARP is disabled, guys. Proxy ARP is not enabled on the router number 2. Now if I'm going to send the packet to the 1.1.1, I can send the traffic because for the all this next hop, right, I'm going to generate the ARP request for the 12.2. And 12.2 is a part of the same broadcast domain. I can send the traffic. Right? All good? For the 2.2.2.2, I can. For the 3.3.3.3, I can. For the 4.4.4.4, I can. For the 5.5.5.5, I can. For the 6.6.6, I cannot. Because for the 6.6.6, he's going to send the ARP request for the destination IP. And proxy ARP is not present on the router number 2. So in that case, I could not send the traffic to the 6.6.6. So always remember one thing, whenever you're going to use the exit interface, make sure that your proxy ARP must be enabled. If your proxy ARP is disabled, you cannot send the traffic. So you may thinking right now, hey, law, I think so this one is good right now. Because for this one, the proxy ARP is not necessary, right? So if I summarize this thing, because I don't want to make the video is so longer. So let me summarize this thing in a very short. So in this case, what happened? If I talk about the pros, right? So what pros we have? Shorter ARP table, right? Of course, for all the if you have a 1000 prefix, right? Let's talk about the IP perspective. If you have 1000 IP, you have a single ARP entry, one ARP entry. So I can save memory and CPU too. And I can increase data performance in that case, right? That's a pros. If I talk about this pros, right? This guy, what we have a pros over there. The pros of this guy is what? Whenever I'm gonna ping 1.1.1.1, right? What happened? My source IP will be 12.1, this interface. Distance IP will be 1.1.1, right? So when this packet comes to router number one, right? When this packet comes to router number one, what router one will say that, hey, let me check my routing table. Do I know about the 1.1.1? According to my routing table, he said, hey, I know the 1.1.1.1. And according to my routing table, I need to forward the packet to the 12.2, right? That's this thing. In that case, what happened? The interface, the exit interface is not mentioned over there. So the first lookup, right? First lookup, what router will do? The first router will do that. Look for the destination guy. Right? Once I look for the destination route, then what happened? I don't know from which interface I need to forward the packet. Then router will do the second lookup. Now the router will do the second lookup for the exit interface. How do I look up for the exit interface? Now it's say, hey, I need to forward the packet to the 12.2. Now I look for where is the 12.2 is connected. So IP route 12.2. The 12.2 is connected by this particular interface. So I need to route the packet from this particular interface. So second lookup I'm doing for the exit interface. This is called as a what? Recursive lookup. And that's why sometime, right, it is known as a static route recursive lookup, static recursive lookup route. Sometimes it's known as a static recursive lookup route as well. So whenever, if you're receiving your 1000 packets, right, if you're receiving a 1000 packets with the next hop concept, then what happened? 2000 times lookup will happen, right? It hit the CPU. So not a good thing, right? So those are the cons we have over there for this guy. I'll come into the pros of this guy. Don't worry. The cons for this guy is what? Recursive lookup. Even if you see, also if you look for the so IP Ceph 1.1.1.1, or if you use the 1.0.0.0.0, and if you put the detailed keyword, you can see that we have a recursive keyword over there. Right? But the same thing, if I look for this guy, the exit interface, in that case, what happened? Let's send the packet. So I want to say, hey, I need to send the packet to whom? I need to send the packet to the 6.6.6.6. So source will be 12.1. 6.6.6.6.6. Packet comes over there. So when this packet comes to router one says, hey, let me look up the 6666. Do I have a 6 in my routing table? According to my routing table, I just need to forward the packet to whom? This interface 0/0. So I just route the packet. I just route the packet in from this interface. So in that case, I don't need to do the recursive lookup. So only one time lookup will happen. That's all. So now if you see this guy, show IP Ceph 6.0.0.0.0 and submit mask detail. So sorry, you don't have any recursive keyword over there. Right? You don't have any recursive keyword over there. So this is also known as a recursive static route. In a recursive static router, what happened? The lookup will happen multiple times, and that's not a good for the router, right? But in the exit interface, recursive is not happening. Only the problem is what? So the pros is what? We don't need to do the recursive lookup. But the cons of this guy is what? We have a multiple ARP entry. We have a multiple ARP entry. For each IP address, we need to maintain the ARP entry. Another thing is that, right? Another thing is the cons is what? We need a proxy ARP. But in this cons, what we have, we just have a recursive lookup. And the pros is what? No need a proxy ARP. So that's a major. So if you see, everyone has a pros and cons. So this also has a pros and this also has a cons over there, right? But if you see, this also has a pros and this also has a cons. So we do need to do the recursive lookup in the exit interface, right? In the next hop, what happened? We need to do the recursive lookup. You see the recursive keyword over there. We don't have any recursive keyword over there. But for this guy pros is what? No need to maintain the proxy ARP. Sorter ARP table we have, right? You just have a one ARP entry, right? If you see the above one, I'll show you. Come on. If you see, for the all the exit interface, I have a multiple ARP entries, right? And for this guy, what happened? I just have a single ARP entry for the, all the next hop. So if you look, right, everyone has their own pros and cons, right? So to avoid this problem, right, we have introduced the concept of combination. We have introduced the concept of what? IP root, destination network, right? Subnet mask information. Then we have an exit interface. And then we need to go with the next hop. So in that case, what happened? The first thing, if I'm going to use the combination, right? Router 1 will generate the ARP request for the next hop only. That's a beauty part. No need to maintain what? Proxy ARP, right? No need to enable the proxy ARP, right? And you will have a shorter ARP table. Am I going to do the recursive lookup? No recursive lookup. So that's a beauty part we have. So if you see, I'll just give you the example of the few routes. So I'll just create the some route over there as the 100.0.0.0/8 and maybe 101.0.0/8 as well. So two route I'm going to create, right? Just to show you that. So let me create this loop back first of all on the router number 2, interface loop back number 100 as the 100.100.100.100, right? And interface loop back number 101, IP address 101.101.101.101/8 over there. All done. Guys, if you see, I have disabled the proxy ARP. If you want to enable the proxy ARP, it's a very simple command, IP proxy ARP, that's all. So I'm not going to enable, I just want to show you that without the proxy ARP, you can still send the traffic to this guy. So on the router number 1, what I can do that, on router 1, I'm going to give this command, IP root 100.0.0.0 and the exit interface and 12.2. IP root 100.0.0.0 subnet mask and 0/0 0/0, and this is not 101. I'm so sorry. This is good and this is good. So now let's give this route on the router 1 and have a look. So now if I'm going to send the traffic, if you see first of all one thing, my debug is already enabled, right? Ping 100.100.100.100. I'm going to generate the ARP request for the next hop. No need to maintain the proxy ARP. I have a sorter ARP table. So I already have a ARP entry. That's why it's doing that. Let me do one thing. Let me flush out all the ARP entry. So, I'll remove the all ARP entries. Then he will generate the ARP request. So now if you see as the ping 100.100.100.100, I'm going to join the ARP request for the destination, guys. Now if I'm going to ping the 101, do I need to join the ARP request? No, I already have a ARP table. If you see, so ARP, I already have a ARP entry for the 12.2, my next stop. So I don't need to generate the ARP request for this person. First and beauty part, sorter ARP table we have, right? Second thing is what? I just have a single ARP table. I can send the traffic for both the person. I just have a single ARP table. Second thing is what? This two is done, right? This three is done. R1 will generate the ARP request for the next stop that we have seen. Next stop from R1, this is the next stop 12.2. Second thing is what? No need to maintain the proxy ARP. So on the R2, the proxy ARP is disabled. All good. If you see, right? Third thing is what? Sorter ARP table we have. Of course, I just have a single ARP table, right? Fourth thing is what? No recursive lookup. So if you see, show IP Ceph detail, and here we go. I don't have recursive keyword over there, right? So that's a beauty part, and always a recommendation to use this command line in the production network. But it's still the people are using the different ways to configure the static route, right? Because maybe they have no idea, maybe they have different reasons, right? But mostly this is the recommendation to do that. In this case, I don't need to do the double lookup. That's called as a recursive, right? No need to maintain the big ARP table, sorter ARP table. No need to enable the proxy ARP. So you have a multiple beauty part of this thing. But I made a video on this guy as well, on this person as well. And also we have seen the video of this guy as well, right? So that's a major difference, all this one. Okay, I'll make one more video, not more, one more video. I'll make 2 and 3 more videos on the static route. I'll show you the concept, what happened, right? Take example. If the proxy ARP is disabled on the router number 2, can I still send the traffic via the exit interface? Yes, we can do that. I'll show you in the next video. So thank you so much, guys. I'll see you in the next video.